Okay, this is the beginning of Lecture 27, Part 2. In Lecture 27, Part 1, we were looking at the concept that we can calculate the amount of heat energy released when you burn a certain amount of fossil fuel. And then we looked at how energy is transferred from one form to another by work or heat. And now we're ready to talk about how this concept of efficiency, that when energy is transferred, the amount of work you put into the system is never the amount of work that you get back out, because some of the energy transfer is lost in the form of heat, which is not useful energy. And a good way to explain this is this device called a Newton's cradle. There's a picture of it in your book. But what it is basically is just some steel balls hanging from thin threads across a support. And what happens is you can put some work into this Newton's cradle by grabbing a hold of one of these steel balls on the end, and using the work from your hand, pull this ball up. And so say pull it up to here. And when you do that, you do work on this little system, and you increase the potential energy of the ball, the gravitational potential energy, because you pull it higher. Well, so you take it and you pull it up, and then when you take your hand off, then the ball falls back down, and it speeds up as it goes back down, and you have an increase in kinetic energy and a decrease in potential energy. And then the ball crashes in. This is the ball. It crashes into the next ball, which crashes into the next ball, which crashes into the next ball, and then this ball is going to move up this way, say to this position, and when it moves up, it's going to decrease in kinetic energy and increase in potential energy, and then it's going to swing back down and repeat the process, crash, crash, crash. And every time the end ball is going to end up at a higher position, a lower position, until the whole thing comes back to rest again. And the reason why, if the work that you originally put into the system was 100% conserved, then the thing would just be like a perpetual motion machine. It would just keep going and going. But every time these balls crash into one another, some of the energy is converted from kinetic energy to sound energy and to heat. And what happens is then the total energy is conserved, but a little bit of kinetic goes into sound and heat. So there's less kinetic energy hitting the last ball, then less potential energy, less kinetic energy, less potential energy, until the whole thing comes to rest again. So this is this concept of efficiency. The work is not 100% efficient. Some of the energy is always, quote unquote, lost to, in this case, sound or heat. And always when you're transferring energy as work, some of it is going to be lost as heat.